A clay tablet sits in the Oriental Institute in Chicago. Catalog number A30191. Most visitors walk right past it. It's the size of a paperback novel, pressed from river clay, covered in wedge-shaped marks that look like nothing more than abstract decoration. The museum card identifies it as an astronomical observation record, circa 2100 BCE, fairly unremarkable by Sumerian standards. But there is one section of this tablet that has quietly occupied a small circle of planetary scientists, linguists, and archaeoastronomers for over 30 years. A section the mainstream academic world has never fully addressed, because addressing it would require admitting something extraordinary. The Sumerians did not just observe the night sky. They documented it with precision. And according to this tablet, one of the objects they documented was not just a distant wandering point of light. It was a world, with water, with an atmosphere, with what the scribe described as moving bodies of light reflected from great surfaces that stretched from horizon to horizon. They were describing oceans on Mars, and then they recorded the exact moment those oceans disappeared. If you want to see more ancient mysteries that challenge everything we were taught about the ancient world, hit subscribe. I cover forgotten civilizations and suppressed discoveries every single week. Now let me show you what this tablet actually says. The Oriental Institute acquired A30191 in 1934 as part of a bulk purchase from a private collector in Baghdad. Its provenance traces back to excavations at Nippur, the ancient Sumerian city that served as the cultural and religious center of Mesopotamia for over 3,000 years. Nippur was, in the ancient world, what the Vatican is today. It was not a political capital, but the seat of cosmic authority. The city where heaven and earth were said to connect. The scribes of Nippur didn't record gossip. They recorded what mattered, what they saw, what they measured. A30191 focuses almost exclusively on one planet. The Sumerians called it Nergal. We call it Mars. The tablet dedicates over 60 lines of cuneiform text to describing Nergal in a way no other tablet does. Not just its position in the sky, its surface, its color, the light it reflected, and something the Sumerians called its skin of mirrors, a phrase that first-century translators assumed was mythological embellishment describing the god Nergal's divine radiance. It wasn't embellishment. In 1971, a linguist named Dr. Raymond Gestin at the École pratique des hautes études in Paris produced what was considered the definitive translation of A30191. Where the text used unusual astronomical terminology, Gestin rendered it as metaphor, as divine language, as poetic license. The phrase Ki Anag Nergal, which appears 7 times in the tablet, Gestin translated as the drinking waters of Nergal, a ritual phrase he argued was associated with offerings made to the war god before battle. That interpretation stood for decades. In 2003, a Sumerologist at Johns Hopkins named Dr. Francesca Rochberg was compiling a reference volume on Babylonian astronomical terminology. While cross-referencing Gestin's translation against newer lexical databases, she noticed something. The word Ki Anag did not appear exclusively in ritual contexts. In trade records, geographical tablets, expedition logs, the same phrase was used consistently to mean a body of water that could be traversed. A sea. Something navigable. The drinking waters of a god was not a ritual offering. It was a description. The Sumerians were describing bodies of water on the surface of Mars. Rochberg published a footnote in her 2004 volume noting the discrepancy. She did not make broader claims. She was careful, academic, but the footnote was noticed. When you strip away a century of interpretive layering and read A30191 through its literal astronomical context, the picture that emerges is precise. The tablet opens with standard data. It begins with the regnal year of King Shulgi of Ur, the month of Ululu, late August and September in the modern calendar. Atmospheric notations, clear skies, no wind, 3 planets visible before moonrise. Then it shifts into a detailed planetary study. The scribe describes Mars in specific terms. Its color, the redness of cooling copper, consistent with what we now know about the planet's iron oxide surface. Its angular size relative to surrounding stars is unusually large, suggesting a favorable opposition when Mars passes closest to Earth in its orbit. Then comes the passage nobody wanted to explain. The scribe writes that Nergal carries on its face the skin of mirrors, moving light that crosses from edge to edge as Nergal turns. He records this observation across multiple nights. He notes the reflective areas shift, not like fixed terrain, but like water, like surfaces that catch and throw back the light of the sun as they move. Glinting, reflecting. Ocean-scale bodies of liquid on a turning world. He does this for 11 consecutive nights. And then the tablet changes. The 11th night's entry is the longest on the tablet, and the most unusual. The scribe begins in standard format. Then, mid-sentence, the tone shifts. Under magnification, scholars have noted that the impression depth of the cuneiform increases on this section, as if the scribe was pressing harder into the clay. Writing with urgency. He describes a change in Mars's appearance. The skin of mirrors, he says, has not just shifted in its nightly rotation, it has contracted. The areas of reflected light that stretched across Nergal's visible face are, in his words, retreating toward the cold places. He uses the Sumerian word kalam mabi, which in geographical texts means the land at the boundary of things, the edge, the pole. The reflections were migrating toward the poles of Mars. Then, on the 12th night, they were gone. Not dimmed, not reduced. Gone. The scribe writes it-til, a word that carries the specific connotation of a complete ending. Not a disappearance implying return, not a setting below the horizon, a ceasing, a finality. The skin of mirrors ceased. He records the exact position of Mars in the sky at the moment he made this observation, the exact phase of the moon, the exact stars it was near. And then, in what feels even across 4,000 years like an act of profound unease, he records it again. The same data, same position, same moon phase, same stars. As if he could not believe what he was seeing, as if he needed the record to prove he had witnessed it. We know today that Mars had liquid water. This is not fringe speculation. It is peer-reviewed consensus. NASA's Mars Reconnaissance Orbiter has mapped ancient riverbeds, lake basins, and shoreline formations across the Martian surface. Isotopic analysis of Martian meteorites has definitively established that water existed on Mars in substantial quantities for approximately the first 1 to 2 billion years of the planet's history. The Standard Model says Mars lost its liquid surface water somewhere between 3 and 3.5 billion years ago, when the planet's magnetic field collapsed and solar wind stripped away its atmosphere. 3 billion years ago, the Sumerians wrote their tablet in 2094 BCE, 4,000 years ago, not 3 billion. So the timeline appears irreconcilably broken. Except that not all planetary scientists agree Mars lost its water 3 billion years ago. In 2015, a team at the European Space Agency published findings from the Mars Express mission showing evidence of geologically recent episodes of liquid water near the Martian surface. not billions of years ago. Thousands, tens of thousands. Localized events driven by volcanic activity or subsurface heat. In 2020, researchers using MAVEN mission data published a paper in Science showing that Mars loses water episodically and rapidly during periods of intense solar activity. During planet-wide dust storms, water is lofted into the upper atmosphere where solar radiation breaks it apart and solar wind carries it away. The process is not slow and linear. It is sudden, punctuated. Mars can, in a geologically short window, shed enormous quantities of water during a single intense solar event. Nobody has modeled whether a visible surface water event on Mars would have been detectable from Earth with the naked eye during the opposition of late August 2094. BCE, nobody has run that simulation. Or if they did, nobody published it. The scribe who carved A301991 was not a philosopher or a mystic. He was a civil servant of the cosmos. His job was to watch the sky every night and write down exactly what he saw. He had no theory about what Mars was. He had no concept of other worlds, other atmospheres, other seas. He had only what his eyes told him across 11 clear nights over Nippur 4,000 years ago. He saw light moving across the face of Nergal in patterns that resembled nothing he had ever recorded. He measured it, and then he watched it disappear. He wrote it down. He pressed the stylus harder into the clay on that final night. He recorded the same observation twice, and then he moved on to the next entry. The next night, the next position of the moon. He had documented something impossible and returned without ceremony to his work. Because that was his job. He didn't decide what it meant. He only decided it happened, that it was real, that it deserved to be carved into clay for whoever came after. The tablet is still in Chicago, still labeled routine, still waiting for someone to run the simulation. If you want to see more ancient records that challenge what we think we know about the solar system and the civilizations that watched it, subscribe now. Next week I am covering the Akkadian cylinder seals that depict a 9-planet solar system, 300 years before the outermost planets were discovered. You will not want to miss it. The video on screen goes deeper into another Sumerian astronomical record that modern science is only now beginning to verify. Click it.